So this guy up here is the dye laser that I was talking about. So this big dye laser has these things. So it has the gain medium. The gain medium is dye, just like you would find in Mountain Dew or something. And there's a jet of dye that comes in here and shoots across this tiny little section. So it makes a really nice flat profile. It looks like if you were to slice it, the cross section looks like a dog bone. So it's like a flat section with like two rounded edges. And so the dye shoots straight across, and then there's a catch tube that goes out and just keeps pumping it around. But the dye by itself won't work, so you need to pump it, and it's pumped by an argon laser that comes out here. So you shoot an argon laser in here, that really strong, like 10-watt beam hits the dye and pumps it up, and then the dye can do its own lasing, separate from what the argon laser is doing. And so the cavity itself, the mirrors, this particular arrangement is called a ring laser, a ring dye laser. And so there is a mirror up here. There's a mirror down here. There's a really tiny mirror inside this little box.
Can you show the mirrors again?
Sure. So there's this mirror right here. There's this guy right here. This guy.
Yeah.
And then there's this guy down here.
Okay.
And then inside this little cage is a really tiny mirror in there. And then those mirrors send the light in a nice ring. It looks like something like that. Like we have a little angular kind of Pac-Man formation or something like that. But then the mirror out here, this is the last mirror. That's called the output coupler. So the light is bouncing around in this ring, and all of these mirrors reflect 100% of the light, because you don't want to lose any of that light, except for the output coupler, which is like 99.99%. So like 0.1% of the beam gets out, and that's the beam that you use. That beam might be like 400 milliwatts or something like that, way more powerful than that guy. But if you go from like a 10-watt argon beam, when it's inside here, it's maybe a couple watts, and then when it gets out here, it's like a couple hundred milliwatts. Compared to this guy, which is like probably less than 5 milliwatts. Inside this guy right here is that etalon I was talking about. So you broadband lays, and then you there's some etalons in there. The etalons are actually really just thick pieces of glass, and so the light kind of bounces back and forth on the edges of the glass, and then that lets you pick out one of those things to get the single mode laser. There's another one right here. This thing inside here. You're going to see that tiny little piece of glass that has plagued me during grad school because I'm so worried about breaking that. Every time I clean that, I think I'm going to like have to spend thousands of dollars to replace it.
Hold on. Where is it?
This tiny little piece of glass here. That tiny little piece of glass is how you scan the laser. That's called the Brewster plate. And so when I want to scan this laser, a signal goes to here that just slightly rotates it, and that very slightly changes the way it's rotating. That's how it works. So that's that. Inside this guy right here, something called an optical diode. And an optical diode works like an electronic diode. It only sends light in one direction, which is this way. And you want it to go out the beam like that. So you get this going across there. And so this does look very complicated. All of this stuff, this big metal bar that's going across the middle, that's called an invar bar. An invar bar is made of a specific kind of metal that does not expand or contract very much with temperature. Because the alignment of this, as soon as I move those mirrors apart by half a wavelength, everything's out of whack again, right? So it's all mounted on this bar that will not move with temperature or expand very much. This big thing in here, not really talking about, this is a wave meter. It's just a way to tell what wavelength is coming out. There's a couple sensors in here that we can use for like checking power and things like that, but generally, it's the gain medium, which is the dye right here, the mirrors, which in this case make a big ring, and then the pump laser that comes in from the outside. This middle part is called the birefringent filter. There's actually two etalons. There's like a big etalon and a skinnier one, because it turns out that the first one might only grab like 3 of them, and so you need another one to get even further down. So this, in this particular case, the gain meter, like I said over here with the dye laser, the gain profile is so wide that you have to kind of cut it down twice to get to a single wavelength. So there's an etalon in here and then another etalon over here.